in the realm of space exploration, innovation and resilience are vital. Lauren Ameen embodies these traits as she leads the Cryogenic Fluid Management Portfolio Project Office at NASA's Glenn Research Center. Her team is tasked with a critical mission, developing advanced technologies to keep rocket fuel cold for extended periods, a necessity for future human expeditions to the Moon and Mars. Ameen's determination is evident in her response to challenges. Her mantra "Watch Me" signals a commitment to overcoming obstacles that may seem insurmountable. Ameen and her colleagues are working on crucial advancements that could significantly impact the feasibility of long-duration missions. As NASA prepares for its ambitious goals of returning humans to the lunar surface and eventually sending astronauts to Mars, efficient cryogenic management becomes essential. The implications of their work extend beyond just fuel. They play a pivotal role in ensuring the safety and success of future missions. Meanwhile, the agency is not only focused on innovation but also on community resilience in the face of natural disasters. Governor Gavin Newsom recently visited the Jet Propulsion Laboratory (JPL) in California to meet with workers affected by the recent Eaton Fire, which devastated numerous homes and businesses in the area. Over 100 employees at JPL faced displacement, prompting the facility to establish a disaster relief fund that has raised over $2 million to support those impacted. During his visit, Newsom highlighted the state's ongoing efforts to assist communities in rebuilding. Thousands of hardworking Californians lost their homes, their businesses, and their livelihoods to this firestorm, he acknowledged, emphasizing the long-term recovery that lies ahead. The state has mobilized resources, including business advisors and disaster assistance programs, to help those affected navigate the challenges of rebuilding. In a parallel development, NASA has been making strides in technology that could redefine exploration on other planets. The agency recently unveiled a prototype tire designed for Mars rovers utilizing a revolutionary shape memory alloy spring system. Unlike traditional materials, these tires can endure significant deformation while retaining their original shape, a crucial feature for navigating the rugged terrain of Mars. Santo Padula, a materials research engineer at NASA, explained, "We can actually deform this all the way down to the axle and have it return to shape, which we could never even contemplate in a conventional metal system." This innovative tire design aims to enhance the durability of rovers, which have historically suffered damage from the harsh Martian environment. As NASA prepares for future missions, including potential crewed explorations, the need for resilient materials is paramount. The knowledge gained from these advancements could also be applicable to structures on the Moon, where habitats must withstand micrometeorite impacts. In another significant shift, Bill Nelson has stepped down as NASA administrator as the political landscape changes with the onset of Donald Trump's second term. Nelson served as NASA chief during a transformative period that included the launch of the James Webb Space Telescope and the Artemis program. His departure marks the end of an era, and the appointment of Janet Petro as interim administrator signifies a new chapter for the agency. As NASA navigates these transitions, both technological and administrative, the focus remains on fostering innovation and resilience. The agency's commitment to advancing space exploration and supporting its workforce in times of crisis underscores its pivotal role in shaping the future of humanity's presence beyond Earth. Looking ahead, the developments in cryogenic technology, advanced materials, and leadership will undoubtedly influence the trajectory of space exploration, paving the way for new milestones and discoveries in the years to come. In an ambitious leap towards humanity's future in deep space, NASA is planning to launch the Gateway, a revolutionary lunar space station that could redefine our approach to extraterrestrial exploration. Set to be launched no earlier than 2027 by a SpaceX Falcon Heavy rocket, Gateway aims to facilitate long-term human habitation beyond Earth, marking a significant milestone in NASA's Artemis program, a mission that symbolizes not just a return to the Moon but an eventual journey to Mars. The Gateway station will orbit the Moon, situated approximately 1,000 times farther from Earth than the International Space Station (ISS). Unlike the ISS, which has hosted astronauts for decades at a relatively close distance of 250 miles. Gateway will serve as a vital outpost for astronauts on lunar missions, allowing for a floating base camp that can support human activities on the Moon for at least 15 years. Initial components of the Gateway, including its essential power systems and living quarters, will be launched and assembled in lunar orbit. Astronauts are expected to inhabit the station during the Artemis 4 mission, anticipated no earlier than September 2028. John Alanson, manager of the Gateway program, emphasized the strategic importance of this venture, stating, "Gateway is really the cornerstone of the Artemis architecture. It really creates that foundation." This infrastructure is projected to enable NASA to test autonomous space technologies, ultimately preparing for future missions to Mars. While the Gateway project is hailed by some as a critical step towards sustainable space exploration, it has not been without controversy. Critics, including former NASA officials and astronauts, argue that establishing Gateway is an expensive detour that could delay direct lunar landings and the essential practice of long-term space living. They contend that Gateway exists primarily to utilize hardware developed under previous administrations and is a costly undertaking that may not yield the expected benefits in terms of advancing human spaceflight capabilities. The origins of the Gateway project can be traced through the shifting priorities of various U.S. presidential administrations. From George W. Bush's Constellation program to the Obama administration's Asteroid Redirection Initiative and Donald Trump's focus on direct lunar landings, the political landscape has significantly influenced NASA's exploration goals. Jack Burns, an astrophysicist at the University of Colorado Boulder, remarked on the historical fluctuations, noting, "It has been frustrating to see major swings in NASA's exploration goals over the past 35 years. However, consensus across administrations has emerged on the need for a transitional phase where astronauts can acclimate to long-distance space living, whether on the Moon, an asteroid, or a space station like Gateway." Gateway is envisioned not only as a base for lunar exploration but as an essential precursor for establishing human presence on Mars. Emma Lenhart, the station's planning and control manager, articulated this vision by stating, "We are learning how to live and work, quote-unquote, off the land," suggesting that Gateway will be instrumental in developing the necessary technologies and strategies for sustainable life beyond Earth. In addition to its logistical functions, Gateway will serve as a platform for scientific research and experimentation. It is expected to host studies on radiation exposure, vital for understanding the risks astronauts face in deep space. Terry Virts, a former astronaut, highlighted the dangers inherent in lunar orbit, where radiation levels are significantly higher than those experienced on Earth or even within the ISS. As Gateway begins to take shape, it will also adapt to the realities of life in space. Astronauts will have shorter missions on Gateway, ranging from 1 to 3 months compared to the longer stints typically experienced on the ISS. This design aligns with studying the psychological impacts of space habitation, as astronauts will be isolated from their home planet, observing Earth as a distant orb from the station. Looking ahead, the future of Gateway and the Artemis program remains intertwined with political realities and technological advancements. The Biden administration has maintained the overarching goal of lunar exploration, but with a new presidential administration on the horizon, the specifics of continued support for Gateway could change. As NASA continues to lay the groundwork for humanity's expansion into the cosmos, the success of Gateway could very well dictate the pace and scope of future missions to the Moon and Mars. In this ever-evolving landscape of space exploration, one thing is clear: Gateway represents a bold step into an uncharted future where humanity aims not just to visit other worlds but to dwell among them. As we aim for the stars, the lessons learned from this lunar outpost will be pivotal in shaping our ambitions for interplanetary colonization. In a remarkable display of the beauty of our universe, NASA astronaut Don Pettit has captured a stunning photograph from the International Space Station (ISS) that offers a breathtaking glimpse of Earth and the cosmos. The image, shared widely on social media, showcases the mesmerizing glow of the Milky Way, punctuated by countless stars, the subtle shimmer of the zodiacal light, and even the faint trails of satellites traversing the darkness. This celestial snapshot not only highlights Pettit's growing photography skills during his third stint aboard the ISS but also serves as a testament to the unique vantage point astronauts enjoy as they orbit our planet. Pettit's passion for capturing images of Earth reflects a broader trend among astronauts who often take advantage of their rare perspective to document the planet below. The ISS orbits Earth approximately every 90 minutes, allowing crew members to witness 16 sunrises and sunsets daily, a rhythm that fosters both a sense of wonder and a profound connection to the home they have temporarily left behind. Astronauts like Tim Peake from the European Space Agency have previously shared their techniques and equipment for photographing Earth, detailing how specialized lenses can reveal intricate details of cities and landscapes from 250 miles above. While Pettit focuses on photography, other members of the Expedition 72 crew are busy preparing for critical scientific work outside the ISS. Scheduled for January 30, 2025, the team will conduct their second spacewalk of the year, during which they will remove communication gear and search for potential microbes on the station's exterior. With ongoing research focused on advanced space navigation and the analysis of microbial DNA, the ISS continues to serve as a vital platform for scientific advancement and exploration. As NASA looks beyond the confines of low Earth orbit, plans are underway for the Gateway, a lunar space station that will facilitate humanity's long-term presence in deep space. This initiative, part of the Artemis program, aims to establish a base for astronauts to live and conduct research in lunar orbit. Scheduled for initial launch in 2027, Gateway will serve as a stepping stone for future missions to Mars and beyond, marking a significant evolution in humanity's exploration aspirations. Gateway's development is rooted in the complex political landscape that has influenced NASA's ambitions over the past decades. Each presidential administration has shifted the agency's focus, leading to changes that have sometimes slowed progress. As the Artemis program gains momentum, it remains to be seen how the incoming administration will shape its trajectory. The program has garnered bipartisan support, emphasizing international collaboration with space agencies from Europe, Japan, Canada, and the United Arab Emirates, all contributing to the Gateway project. Critics of the Gateway initiative argue that it may complicate lunar missions by adding unnecessary layers of cost and logistical challenges. However, advocates assert that it is essential for developing the skills and technologies needed for longer missions to Mars. The Gateway will provide critical data on radiation exposure, habitat sustainability, and resource utilization, paving the way for future exploration. As NASA prepares for these ambitious endeavors, the focus remains on ensuring the safety and well-being of astronauts in space. The experiences aboard the ISS and the upcoming Gateway will serve as invaluable lessons in human spaceflight, allowing NASA to refine its strategies and technologies. The future of space exploration is ripe with potential, and as humanity continues to reach for the stars, the stories of astronauts like Don Pettit remind us of the beauty and wonder that lies just beyond our atmosphere. With each mission, we take another step toward understanding our place in the universe and the possibilities that await us among the stars. In a remarkable display of human ingenuity and resilience, NASA's Expedition 72 crew aboard the International Space Station ISS is hard at work, balancing rigorous spacewalk preparations with groundbreaking scientific research. As they gear up for their second spacewalk of the year on January 30, the crew is not only tackling the practicalities of life in orbit but also pushing the boundaries of what we understand about space and our own biology. On January 16, astronaut Nick Hague captured a stunning space selfie featuring the NICER X-ray telescope reflected in his helmet visor, epitomizing the intersection of exploration and technology. The upcoming spacewalk is set to focus on removing outdated communication equipment and conducting a vital search for microbes that might survive in the harsh environment of space. Station Commander Suni Williams and Flight Engineer Butch Wilmore are meticulously organizing tools and reviewing procedures to ensure a smooth operation. Scheduled to begin at 8 a.m. Eastern Standard Time, the spacewalk will involve swabbing external surfaces to assess microbial resilience outside the ISS. Hague and fellow flight engineer Don Pettit are also engaged in vital scientific tasks. Haig has been working in the Columbus Laboratory module installing a Navcom technology demonstration that aims to provide a backup navigation solution for future lunar missions. Meanwhile, Pettit has been sequencing DNA from bacteria residing in the ISS water systems. This innovative research part of the Gizmos biotechnology study allows for rapid microbial analysis without the need to return samples to Earth, a crucial step in safeguarding astronaut health on long-duration missions. The crew's work extends beyond immediate spacewalk preparations. Flight engineer Alexei Ovchinin is exploring future spacecraft operations using advanced sensors, while Ivan Vanner and Alexander Gorbanov are focused on maintaining the station's electronic systems and conducting Earth observation experiments, respectively. Their efforts highlight the ISS's role as a unique laboratory for both scientific inquiry and operational training. In a parallel effort, NASA is pioneering advancements in rover technology for future planetary exploration. The agency has been testing innovative shape memory alloy SMA tires that could revolutionize rover mobility on Mars and beyond. Traditional rover tires have proven vulnerable to the planet's rugged terrain, which has hindered exploration. However, SMA tires developed in collaboration with Goodyear can deform significantly under stress and return to their original shape, providing enhanced durability and performance. Santo Padula, a materials research engineer at NASA Glenn, explained the advantages of this new technology. We can actually deform this all the way down to the axle and have it return to shape, which we could never even contemplate in a conventional metal system. This breakthrough could allow future rovers to navigate the Martian landscape more effectively, reducing the risk of punctures and damage. The potential applications of SMAs extend beyond rover tires. NASA is investigating their use in habitat construction for lunar and Martian missions, where their energy-absorbing properties could protect against micrometeorite impacts, an essential consideration for ensuring the safety of human explorers on these celestial bodies. In a further initiative to harness technological innovation, NASA has launched the Sustainable Business Model Challenge, encouraging entrepreneurs to utilize its Earth system science data to develop solutions for climate challenges. Participants are invited to submit business concepts that integrate NASA's climate data with the goal of fostering sustainable solutions to support vulnerable communities and ecosystems. With the next frontier of space exploration rapidly approaching, NASA's ongoing research and development efforts are laying the groundwork for sustainable human presence on the Moon and Mars. As the agency continues to refine technologies for both space travel and the challenges of climate change, the future holds exciting possibilities for exploration, innovation, and resilience. As we look ahead, the work being done in orbit and on Earth today will shape the narratives of our journeys into the cosmos. In a bold leap towards enhancing extraterrestrial exploration, NASA has unveiled groundbreaking advancements in rover mobility through the development of innovative tire technology. The agency's Glenn Research Center has tested a new type of tire known as a shape memory alloy SMA spring tire, which promises to revolutionize how rovers navigate the rugged terrains of Mars and potentially other celestial bodies. NASA's recent tests, conducted on Martian simulated surfaces at Airbus Defence and Space in the United Kingdom, demonstrated the tire's remarkable ability to absorb significant deformation without sustaining damage. Santo Padula, a materials research engineer at NASA Glenn, emphasized the potential of this technology, stating, "We can actually deform this all the way down to the axle and have it return to shape, which we could never even contemplate in a conventional metal system." This flexibility could prove vital, as current rovers like Perseverance and Curiosity have faced considerable wear and tear from the harsh Martian environment, often resulting in punctured tires and reduced mobility. Traditional rover tires have typically been made from aluminum or steel materials that struggle under extreme stress. In contrast, the SMA spring tires utilize a nickel-titanium alloy that can withstand intense pressures without permanent deformation. This breakthrough is critical, particularly for future missions that may involve crewed vehicles on Mars or the Moon, where repairing a flat tire is not a feasible option. The SMA tire's resilience could significantly enhance the longevity and performance of rovers as they traverse the challenging Martian landscape. The implications of this technology extend beyond rover mobility. Padula pointed out that SMA materials could also be instrumental in constructing habitats for astronauts on the Moon. Given the Moon's lack of a protective atmosphere, structures will need to withstand micrometeorite impacts, and SMA materials with their energy-absorbing properties could serve as effective shields. We need new materials for extreme environments that can provide energy absorption for micrometeorite strikes, Padula noted, highlighting the dual-purpose potential of SMAs in both exploration and habitation. The recent advancements in SMA tire technology come at a pivotal moment in space exploration, coinciding with renewed commitments from government and private sectors to advance human missions to Mars. President Donald Trump's recent inaugural address reaffirmed his administration's dedication to sending astronauts to the Red Planet, aligning with SpaceX's ambitious plans to develop a crewed starship capable of making the journey. However, as the timeline for such missions remains ambitious, with various technological and logistical hurdles still to overcome, the focus on durable and efficient exploration technology like SMA tires becomes increasingly critical. As NASA continues to refine and test SMA technologies, the future of rover mobility and extraterrestrial habitat construction looks promising. With the potential to traverse more of Mars's surface and withstand the extremes of outer space, these innovations are paving the way for a new era of exploration. As we stand on the brink of interplanetary exploration, the developments in SMA technology signal a significant step forward, promising not only to enhance our understanding of the cosmos but also to lay the groundwork for sustainable human presence on other planets. In a significant leap for lunar exploration, Firefly Aerospace's Blue Ghost lunar lander has embarked on an ambitious journey to the Moon, marking a pivotal moment in NASA's Artemis campaign. Launched on January 15, 2025 aboard a SpaceX Falcon 9 rocket, Blue Ghost is designed to deliver 10 NASA science and technology payloads to the Moon's surface, potentially becoming the second American craft to achieve this feat in nearly 5 decades. The mission's first milestone was achieved just 4 days post-launch, when Blue Ghost successfully completed its inaugural engine burn, a crucial maneuver that positions the lander on a trajectory toward the Moon. Following 25 days of orbiting Earth, Blue Ghost will commence its 4-day journey to lunar orbit, where it will spend an additional 16 days before beginning descent operations. As NASA's Deputy Administrator Pam Melroy aptly noted, the mission embodies the bold spirit of NASA's Artemis campaign, a campaign driven by scientific exploration and discovery. One of the mission's highlights is the Lunar GNSS Receiver Experiment LUGRE, jointly developed by NASA and the Italian Space Agency. This groundbreaking technology demonstration has successfully acquired Global Navigation Satellite System (GNSS) signals at nearly 52 Earth radii, equivalent to more than 205,674 miles from Earth. This achievement not only establishes a record for Earth-Moon signal distance but also showcases the potential for Earth-based GNSS constellations to facilitate navigation in space, extending the capabilities of existing navigation systems. Throughout its mission, LUGRE will continue to advance our understanding of how these systems can be utilized beyond Earth, including during lunar operations. While Blue Ghost is on its mission, it also captured stunning visuals from space, including footage of Earth eclipsing the Sun, providing a glimpse into the beauty of space travel. As the lander approaches its scheduled lunar touchdown on March 2, 2025, it will be testing various technologies such as lunar regolith collection and the use of GPS on the Moon. The significance of this mission extends beyond the immediate scientific objectives. It represents a renewed global interest in lunar exploration reminiscent of the Apollo era, with multiple nations and private enterprises vying to contribute to our understanding of the Moon. Alongside Blue Ghost, the Japanese Hakuto R lander is also en route to the Moon, further illustrating the collaborative spirit that characterizes current lunar initiatives. The Artemis program, which aims to establish a sustainable human presence on the Moon, is a cornerstone of NASA's broader vision for future space exploration, including eventual missions to Mars. As NASA prepares to retire the International Space Station ISS in favor of new endeavors, the Gateway Lunar Space Station is set to play a critical role in facilitating human exploration of deep space. Scheduled for its first launch in 2027, Gateway will serve as a staging point for lunar missions and a platform for testing technologies essential for long-duration space travel. However, the Gateway initiative has faced scrutiny, with some experts questioning its necessity and feasibility. Critics argue that resources could be better allocated directly to lunar surface operations rather than investing in a lunar orbiting outpost. Yet advocates maintain that Gateway is essential for training astronauts and developing technologies needed for future Mars missions. As the Blue Ghost mission continues, it is clear that the resurgence of lunar exploration is not merely a return to past achievements but rather a foundation for future advancements in space science and technology. With each step taken, NASA and its partners are paving the way for a new era of discovery, one that holds the promise of unlocking the mysteries of the moon and beyond. As we look ahead, the collaboration between government agencies and private enterprises will likely play a crucial role in shaping the future of human space exploration, with the moon serving as a critical stepping stone toward Mars and the greater cosmos.